Albert Einstein remains one of the most significant figures in human history, a name synonymous with genius, scientific revolution, and intellectual curiosity. His contributions to physics not only reshaped the scientific landscape but also altered humanity's understanding of the universe. Einstein's impact extends beyond equations and theories. His influence permeates philosophy, education, and even politics. From redefining space and time to advocating for peace and human rights, Einstein's legacy is as profound as it is multifaceted. The 20th century was an era of unprecedented scientific and technological advancements, but few individuals contributed as profoundly to these developments as Einstein. His name is often mentioned alongside Newton and Galileo, as he redefined fundamental laws of physics and created entirely new ways of thinking about reality. His work on relativity transformed physics, while his insights into quantum mechanics laid the foundation for modern technology, from lasers to semiconductors. His theories were not just theoretical breakthroughs. They revolutionized practical applications, shaping fields ranging from nuclear energy to GPS technology. What sets Einstein apart from other scientists is not just the magnitude of his discoveries but also the breadth of his intellectual pursuits. He was not merely a physicist but a philosopher of science, a humanist, and an advocate for world peace. He engaged deeply with existential questions, pondering the nature of reality, free will, and the limits of human knowledge. His famous debates with Niels Bohr over quantum mechanics were not just scientific disagreements but reflections of his deeper philosophical inquiries about the nature of the universe. Einstein's humanitarianism was another defining aspect of his life. Despite his groundbreaking work in theoretical physics, he remained deeply engaged in the social and political issues of his time. He was an outspoken critic of nationalism, a vocal opponent of fascism, and a strong supporter of civil rights. He spoke out against racism in America, supported the establishment of the Hebrew University in Jerusalem, and was an early advocate for global governance to prevent nuclear war. His advocacy for pacifism and social justice was as important to him as his scientific endeavors. His life was a story of brilliance, perseverance, and intellectual rebellion. Born in 1879 in Ulm, Germany, he showed early signs of curiosity but was by no means a child prodigy. Unlike some scientific geniuses who exhibit extraordinary abilities from a young age, Einstein's intellectual gifts emerged gradually. As a child, he was slow to speak, which concerned his parents. Some accounts suggest he did not speak full sentences until he was nearly 4 years old. However, this delay did not indicate a lack of intelligence. Rather, it hinted at his deep contemplation and tendency to think carefully before speaking. One of the pivotal moments of Einstein's early life was when his father gave him a simple compass. At the age of 5, he was captivated by the way the needle moved without any visible force acting upon it. This seemingly trivial event sparked a lifelong fascination with invisible forces, a curiosity that would later drive his scientific inquiries into electromagnetism, gravity, and relativity. Unlike other children who might have played with the compass briefly and then forgotten about it, Einstein spent hours pondering how it worked. This moment marked the beginning of his relentless quest to understand the fundamental laws of nature. Einstein's early education was not entirely smooth. His family moved to Munich, where he attended a Catholic elementary school before transferring to the Luitpold Gymnasium. The rigid, authoritarian structure of German education at the time did not suit him. He disliked rote memorization and was often at odds with teachers who demanded strict discipline. One of his teachers even told him that he would never amount to anything, a statement that would later seem laughable in light of his achievements. Einstein preferred to think independently, questioning everything rather than accepting information passively. Despite his struggles with the traditional education system, Einstein's intellectual development was shaped by his family and mentors. His uncle Jacob, an engineer, introduced him to algebra and encouraged him to solve complex problems. Another influential figure was Max Thomé, a family friend and medical student who lent young Einstein books on science and philosophy. Through these readings, Einstein encountered the works of Kant, Euclid, and other great thinkers, which helped him develop a strong foundation in logical reasoning and abstract thought. By the time he was 12, Einstein had developed a passion for mathematics. He found a book on Euclidean geometry and was amazed by the logical clarity of its theorems. He later described this discovery as an awakening to the beauty of pure reasoning. While other students struggled with mathematics, Einstein devoured advanced topics on his own, mastering differential and integral calculus before reaching his mid-teens. His ability to visualize complex problems in his mind, conducting what he later called thought experiments, set him apart from his peers. However, despite his academic strengths, Einstein's independent thinking clashed with the rigid German school system. In 1894, when he was 15, his father's business failed, and the family moved to Milan, Italy. Einstein stayed behind in Munich to complete his studies but quickly became disillusioned with the strict discipline at school. Unhappy and restless, he eventually left the school without a diploma and joined his family in Italy. This decision could have ended his academic career, but Einstein remained determined to continue his education. He applied to the Swiss Federal Polytechnic School in Zurich, one of the most prestigious scientific institutions in Europe. However, he failed the entrance exam on his first attempt, excelling in mathematics and physics but performing poorly in languages and other subjects. This setback did not discourage him. He spent a year at the cantonal school in Aarau, Switzerland, where the education system was far more liberal and encouraging. Unlike his previous experiences, the Swiss approach to education emphasized critical thinking and creativity, qualities that suited Einstein perfectly. During this period, he continued to conduct his own intellectual explorations. He developed the habit of imagining himself in different physical scenarios, one of the most famous being his thought experiment of chasing a beam of light. He wondered what would happen if he moved at the speed of light alongside a light wave, a question that would later lead to his revolutionary theory of relativity. Even as a teenager, he was thinking about problems that professional physicists had yet to address. In 1896, Einstein successfully passed the entrance exam for the Swiss Federal Polytechnic and officially enrolled in the physics and mathematics program. It was during his time in Zurich that he met Mileva Marek, a fellow student and one of the few women in the field of physics at the time. Einstein and Marek developed a close relationship, bonding over their shared love of science. Some historians speculate that she played a role in his early work, though her exact contributions remain a subject of debate. Einstein's years at the Polytechnic were a mix of academic success and rebellion. He continued to excel in mathematics and physics but was often seen as a difficult student by his professors. He skipped lectures, preferring to study on his own, and frequently challenged his instructors. His independent mindset, while a source of frustration for his teachers, was also a key reason for his eventual success. Unlike many of his contemporaries who followed conventional academic paths, Einstein was already thinking outside the established frameworks of physics. Upon graduating in 1900, Einstein faced an unexpected challenge. He struggled to find a job. His rebellious attitude had not endeared him to his professors, and he lacked strong recommendations. He applied for numerous academic positions but was repeatedly rejected. During this time, he took on various temporary tutoring jobs while continuing to work on his own scientific ideas. In 1902, a breakthrough came when he secured a position at the Swiss Patent Office in Bern. Though the job was not directly related to physics, it provided him with financial stability and, more importantly, ample time to think. As a patent examiner, he was required to evaluate technical inventions, which helped him refine his analytical skills. The structured yet undemanding nature of the work allowed him to dedicate his spare time to scientific research. It was during his years at the patent office that Einstein produced some of his most groundbreaking ideas. He used his free time to explore deep questions about space, time, and light. This period of intellectual solitude allowed him to develop concepts that would soon revolutionize physics. Despite being an outsider to the academic establishment, he was on the brink of publishing papers that would challenge the foundations of classical physics. Einstein's journey from a curious child fascinated by a compass to a young scientist questioning the very nature of the universe was marked by resilience, intellectual independence, and an insatiable desire for knowledge. The coming years would see him transition from an obscure patent clerk to a global scientific icon, forever altering our understanding of reality. Albert Einstein's years at the Swiss Patent Office in Bern proved to be some of the most transformative in his life. From 1902 to 1909, he worked as a technical examiner, reviewing patent applications for electromagnetic devices. Though this position was not prestigious, it provided him with financial stability and, more importantly, ample time to think about physics. The structured routine of the patent office allowed him to reflect on fundamental scientific problems, and it was during these years that he developed some of the most groundbreaking ideas in modern physics. Einstein's job required him to analyze inventions critically, evaluating their novelty and feasibility. This daily exercise of breaking down complex ideas and identifying core principles helped sharpen his analytical skills. Though he was not engaged in formal academic research, the job's intellectual demands complemented his own independent studies. In his spare time, he continued to read scientific papers, conduct thought experiments, and develop his ideas about space, time, and light. The year 1905 would later be known as Einstein's miracle year, annus mirabilis, because he published 4 groundbreaking papers that fundamentally changed physics. These papers were not just incremental contributions, they addressed some of the most pressing scientific problems of the time and introduced revolutionary concepts. The first paper dealt with the photoelectric effect, laying the foundation for quantum mechanics. The second paper provided a mathematical explanation for Brownian motion, offering concrete proof for the existence of atoms. The third paper introduced the special theory of relativity, radically altering our understanding of space and time. The fourth paper presented the famous equation E equals mc squared, establishing the equivalence of mass and energy. In his paper on the photoelectric effect, Einstein proposed that light behaves not just as a wave but also as a particle. This idea directly challenged the classical wave theory of light, which had been dominant since the 19th century. He suggested that light consists of discrete energy packets called quanta, later known as photons, and that when these photons strike a metal surface, they eject electrons. This explanation was revolutionary because it provided the first clear evidence of quantum behavior. Though Max Planck had earlier introduced the concept of quantized energy levels, Einstein's work extended it to light itself. This discovery would later earn him the Nobel Prize in Physics in 1921, though at the time, it was met with skepticism. Many physicists, including Planck, found it difficult to accept the idea that light had both wave and particle characteristics. Einstein's second major paper in 1905 tackled the long-standing mystery of Brownian motion. This phenomenon, first observed by Robert Brown in 1827, referred to the erratic motion of tiny particles suspended in liquid. No one had been able to explain why these particles moved unpredictably. Einstein demonstrated mathematically that this motion was caused by collisions with individual molecules in the liquid. His work provided strong empirical evidence for the existence of atoms, which had been debated for decades. Though atomic theory was widely accepted, direct proof of atoms had been elusive. Einstein's explanation of Brownian motion helped settle the debate, and subsequent experiments confirmed his predictions, solidifying the atomic theory of matter. The third and most famous paper of Einstein's miracle year introduced the special theory of relativity. This theory fundamentally changed the way scientists understood space and time. Before Einstein, physics was dominated by Newtonian mechanics, which assumed that space and time were absolute. According to Newtonian physics, time flowed uniformly everywhere in the universe, and distances were fixed. However, Einstein challenged this view by proposing that space and time were not separate entities but part of a single unified framework, spacetime. Einstein's key insight was that the speed of light is constant in all frames of reference. This meant that time and space must adjust relative to the observer's motion. One of the most startling consequences of this theory was time dilation, the idea that time slows down for an object moving at high speeds. Another was length contraction, which suggested that objects appear shorter in the direction of motion as they approach the speed of light. These ideas were counterintuitive, but they were backed by mathematical rigor and would later be confirmed through experiments. His final paper in 1905 introduced the equation E equals mc squared, which showed that mass and energy are interchangeable. This simple yet profound equation revealed that a small amount of mass could be converted into a tremendous amount of energy. While its practical applications were not immediately realized, this equation would later become the foundation for nuclear energy and atomic bombs. It demonstrated that mass was not just a measure of matter but also a form of stored energy. The scientific community's reaction to Einstein's work was mixed. Some physicists immediately recognized the significance of his contributions, while others were skeptical. His ideas were radical, and many of them contradicted classical physics. However, over the following years, experimental evidence increasingly supported his theories, and his reputation as a brilliant physicist grew. Einstein's rise to prominence did not happen overnight, but by the end of the decade, he had secured a position in academia. In 1909, he left the patent office and took a professorship at the University of Zurich. This marked the beginning of his transition from an obscure patent clerk to a leading figure in theoretical physics. Over the next few years, he held positions in Prague and Berlin, further solidifying his reputation as a groundbreaking thinker. While special relativity had already made Einstein famous among physicists, it was his work on general relativity that would bring him worldwide recognition. Between 1907 and 1915, he worked on extending the principles of relativity to include gravity. Newton's law of gravitation, which had been accepted for centuries, described gravity as a force between two objects. However, Einstein believed this explanation was incomplete. Instead, he proposed that gravity was not a force in the traditional sense but a curvature in spacetime caused by massive objects. His general theory of relativity, published in 1915, introduced the concept that massive objects warp the fabric of space and time, creating what we perceive as gravity. According to this theory, the sun bends spacetime around it, and planets move along curved paths because of this distortion. One of the key predictions of general relativity was that light from distant stars should bend when passing near a massive object, such as the sun. This prediction provided a way to test the theory. In 1919, an opportunity arose to confirm Einstein's theory. During a total solar eclipse, astronomers led by Sir Arthur Eddington observed the positions of stars near the sun and found that their light was indeed bent as Einstein had predicted. This was a groundbreaking moment. When news of the successful experiment spread, Einstein became an international celebrity overnight. Newspapers around the world proclaimed that Newton had been dethroned and that a new vision of the universe had emerged. The media frenzy surrounding Einstein was unprecedented for a scientist. Unlike previous physicists who had worked in relative obscurity, Einstein became a public figure, admired not only for his intellect but also for his personality and unconventional demeanor. His wild hair, absent-minded professor image, and witty remarks made him an icon. His rise to fame coincided with the growing influence of mass media, and his theories became widely discussed outside scientific circles. Despite his professional success, Einstein's personal life was complicated. His marriage to Mileva Maric, which had begun with shared intellectual passion, deteriorated over time. The pressures of his career, financial struggles in the early years, and differences in personality strained their relationship. By 1914, the marriage had effectively collapsed. Einstein moved to Berlin, while Mileva remained in Zurich with their two sons. They eventually divorced in 1919, with Einstein agreeing to give Mileva the prize money from any future Nobel Prize he might win, a promise he fulfilled in 1921. Einstein's growing fame brought both admiration and scrutiny. He became a symbol of scientific progress, but he also faced criticism from political and ideological opponents. As a German-born Jewish scientist, he was targeted by nationalist and anti-Semitic groups, particularly as tensions rose in Europe. Despite these challenges, Einstein remained focused on his work, continuing to explore the implications of relativity and engaging with broader philosophical and humanitarian questions. His transition from an obscure patent clerk to the world's most famous scientist was remarkable. In just 2 decades, he had revolutionized physics, altered humanity's understanding of the universe, and become a global celebrity. His journey was far from over, as he would go on to play a crucial role in scientific and political discussions throughout the 20th century. His discoveries laid the foundation for modern physics, and his influence extended far beyond the realm of science. Einstein's years in Germany marked a period of both intellectual achievement and increasing political turmoil. In 1914, he accepted a position at the Prussian Academy of Sciences in Berlin, which allowed him to focus entirely on research without teaching obligations. This was a prestigious appointment, placing him at the heart of Germany's scientific establishment. During this time, he deepened his work on general relativity, refined its mathematical framework, and engaged with some of the leading physicists of the era. His position in Berlin also gave him access to top resources, allowing him to collaborate with notable scientists and mathematicians. Despite his scientific success, Einstein was never comfortable with the rising tide of nationalism in Germany. During World War I, he was one of the few intellectuals who publicly opposed the war. While many German scientists and academics signed the Manifesto of the 93, a document that justified Germany's militaristic actions, Einstein was among the small group who signed an anti-war declaration. His stance on pacifism made him an outsider in German academic circles, but he remained steadfast in his belief that science should serve humanity rather than political ambitions. Einstein's political activism extended beyond his opposition to war. He was vocal about social justice issues, advocating for civil rights and international cooperation. He supported the establishment of the League of Nations, believing that a global body could help prevent future conflicts. He also became an outspoken supporter of Zionism, not in the sense of religious nationalism, but as a movement to create a safe homeland for Jews facing persecution. His Jewish heritage became increasingly significant to him as antisemitism spread across Europe, and he saw Zionism as a necessary response to growing hostilities. By the late 1920s, anti-Semitic attacks on Einstein intensified. His scientific theories were increasingly targeted by nationalist and racist groups who saw his work as a threat to German physics. A faction of German physicists, including Philipp Leonard and Johannes Stark, rejected relativity as Jewish science and sought to undermine Einstein's contributions. The Nazis, who were gaining political power, fueled these sentiments, branding Einstein as an enemy of German culture. Einstein's fame made him a prime target for Nazi propaganda. His lectures were disrupted, his home was raided, and his life was threatened. In 1933, when Adolf Hitler rose to power, Einstein realized he could no longer stay in Germany. That year, while on a trip to the United States, he made the difficult decision not to return to his homeland. He formally renounced his German citizenship, severing ties with a country that had once celebrated him. The Nazis retaliated by confiscating his property, stripping him of his academic titles, and publicly denouncing him. A Nazi newspaper even placed a bounty on his head, calling for his assassination. Forced into exile, Einstein sought refuge in the United States. He accepted a position at the newly established Institute for Advanced Study in Princeton, New Jersey. Unlike his earlier academic appointments, this role allowed him complete freedom to pursue research without teaching responsibilities. He settled into a quiet life, living in a modest house with his wife, Elsa, and focusing on theoretical physics. At Princeton, Einstein became a prominent public intellectual. Though he was no longer at the center of cutting-edge physics research, his voice carried immense influence. He used his platform to warn about the dangers of fascism, advocate for global peace, and support scientific inquiry. He was particularly concerned about the rise of nuclear weapons, realizing that his own work had inadvertently contributed to their development. During this period, Einstein also became deeply involved in one of the most significant debates in modern physics: the interpretation of quantum mechanics. In the 1920s, quantum mechanics had emerged as a new framework for understanding atomic and subatomic behavior. Pioneered by figures like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, quantum mechanics introduced concepts that challenged classical physics. Central to this new theory was the idea of probability. Rather than definite outcomes, quantum events could only be predicted in terms of likelihoods. Einstein was deeply uncomfortable with the implications of quantum mechanics. He believed in a deterministic universe, where natural laws governed all events with certainty. The probabilistic nature of quantum mechanics seemed to undermine this belief, suggesting that fundamental reality was governed by chance. His skepticism was famously encapsulated in his remark, "God does not play dice with the universe." The most famous intellectual exchange on this topic occurred between Einstein and Niels Bohr. The two engaged in a series of debates, challenging each other's views on quantum mechanics. Einstein tried to develop paradoxes that would expose weaknesses in quantum theory, while Bohr defended the new framework, arguing that quantum mechanics accurately described nature despite its counterintuitive elements. One of Einstein's key objections was the EPR paradox, named after a paper he co-authored with Boris Podolsky and Nathan Rosen in 1935. This thought experiment suggested that quantum mechanics allowed for spooky action at a distance. That is, two particles could be instantaneously connected regardless of the distance separating them. Einstein believed this implied that quantum mechanics was incomplete and that a deeper, hidden structure must exist. However, later experiments confirmed that quantum entanglement was real, further cementing the validity of quantum mechanics. Despite his objections, Einstein's critiques played a crucial role in advancing the field. His challenges forced physicists to refine their theories and led to deeper explorations of quantum mechanics. Though he never accepted the full implications of the theory, his contributions helped shape the debate and inspired new lines of research. Beyond quantum mechanics, Einstein devoted much of his later years to the pursuit of a unified field theory. He sought to develop a single framework that could describe all fundamental forces of nature: gravity, electromagnetism, and eventually, the strong and weak nuclear forces. This ambition stemmed from his belief in the fundamental unity of physics. However, despite decades of effort, he was unable to achieve this goal. The complexities of quantum mechanics and the later discoveries in particle physics made unification more challenging than he had anticipated. Einstein's time at Princeton was marked by a mix of scientific work, public advocacy, and reflection. He continued to engage with world affairs, speaking out against war and racism. He was a strong supporter of civil rights in the United States, forming friendships with figures like W.E.B. Du Bois and Paul Robeson. He also spoke out against the use of nuclear weapons after World War II, becoming one of the leading voices advocating for disarmament. His later years were marked by a sense of isolation from the mainstream physics community. While younger physicists moved forward with quantum theory and new developments in particle physics, Einstein remained focused on his search for deeper theoretical foundations. Despite this, his legacy remained unparalleled. Einstein's exile from Germany and his subsequent life in Princeton reflected his transformation from a physicist into a global symbol of intellect and moral responsibility. He had not only reshaped our understanding of the universe but had also used his influence to advocate for justice and peace. His journey from Berlin to Princeton mirrored the broader upheavals of the 20th century, as science, politics, and philosophy intersected in unprecedented ways. His name became synonymous with genius, and his ideas continued to shape the scientific landscape long after his passing. Einstein's involvement with the atomic bomb began reluctantly and would later become one of his deepest regrets. In the late 1930s, as political tensions in Europe escalated and Nazi Germany expanded its influence, a group of scientists became increasingly concerned about the possibility that Germany could develop an atomic weapon. Among them were physicists Leo Szilard, Edward Teller, and Eugene Wigner, who had fled Europe and understood the destructive potential of nuclear fission, a discovery made by German scientists Otto Hahn and Fritz Strassmann. When word spread that nuclear chain reactions could be harnessed to create an unprecedented weapon, Szilard and his colleagues feared that the Nazis might achieve this first. Despite his pacifist principles, Einstein was drawn into this concern. Szilard approached him in the summer of 1939, believing that his international reputation would lend weight to their warning. Together, they drafted a letter to U.S. President Franklin D. Roosevelt, urging him to take the possibility of a German atomic bomb seriously. The letter explained the theoretical feasibility of nuclear fission and suggested that the United States should accelerate its own research into nuclear energy. Though Einstein had no direct involvement in nuclear research, his name carried enormous authority, and the letter played a crucial role in prompting the U.S. government to fund what would become the Manhattan Project. Once the United States committed to developing nuclear weapons, Einstein was kept at a distance from the project. His political views and associations with socialist and pacifist groups led the military to view him as a security risk. Although he had laid the groundwork for the bomb's development with his famous equation E=mc², which demonstrated the equivalence of mass and energy, he had no direct participation in the research that led to the weapon's creation. By the time the Manhattan Project reached its final stages, Einstein was already regretting his role in alerting Roosevelt to the potential of nuclear weapons. In August 1945, when the United States dropped atomic bombs on Hiroshima and Nagasaki, Einstein was horrified. He had hoped that the mere existence of such weapons would deter their use, but the reality of their devastation shattered any such illusions. The images of charred cities and reports of tens of thousands of civilian deaths deeply affected him. He became an outspoken critic of nuclear warfare, declaring that the world had entered a new, dangerous era. Following the war, Einstein dedicated himself to the cause of nuclear disarmament. He used his global platform to warn about the existential threat posed by these weapons, emphasizing that humanity could not afford another war fought with atomic bombs. He became a leading figure in movements advocating for international cooperation and arms control. He supported the establishment of the United Nations, believing that a global governing body was essential to maintaining peace. Alongside other scientists, he helped create the Emergency Committee of Atomic Scientists, which worked to educate the public about the dangers of nuclear weapons and the need for international oversight. Despite his efforts, Einstein grew increasingly disillusioned with global politics. The Cold War intensified, and rather than curbing nuclear proliferation, both the United States and the Soviet Union escalated their arms race. The detonation of the first hydrogen bomb in 1952, a weapon far more powerful than the bombs dropped on Japan, confirmed his worst fears. He saw world leaders moving toward mutually assured destruction, ignoring the warnings of scientists and intellectuals. As Einstein aged, his focus shifted from active scientific research to broader philosophical concerns. Though he continued to work on theoretical physics, particularly his elusive search for a unified field theory, he found himself increasingly disconnected from mainstream physics. The rapid advancement of quantum mechanics, a field he had once helped pioneer, moved in directions that he fundamentally disagreed with. Many younger physicists embraced quantum indeterminacy, while Einstein remained convinced that deeper, hidden laws govern the universe. His opposition to the dominant interpretations of quantum theory left him somewhat isolated within the scientific community, though his influence remained immense. Beyond science, Einstein became an outspoken advocate for human rights and social justice. He was deeply troubled by racial segregation in the United States, which he saw as a moral failing of a nation that prided itself on democracy and freedom. He was particularly vocal about the mistreatment of Black Americans, supporting the civil rights movement long before it gained mainstream momentum. He formed friendships with figures like W.E.B. Du Bois and Paul Robeson, lending his name and influence to their causes. When Du Bois was targeted by the U.S. government during the McCarthy era, Einstein publicly defended him, refusing to be intimidated by the growing climate of political repression. Einstein was also a critic of McCarthyism, the anti-communist hysteria that swept through the United States in the early 1950s. He viewed the government's persecution of intellectuals, artists, and activists as a dangerous suppression of free thought. He openly condemned the House Un-American Activities Committee and encouraged those called to testify to refuse cooperation. His defiance of McCarthyism further distanced him from mainstream American political circles, but he remained steadfast in his principles. In his later years, Einstein often reflected on the intersection of science, philosophy, and spirituality. Though he did not adhere to any organized religion, he spoke frequently about a sense of cosmic order and wonder. He famously stated that he believed in Spinoza's God, referring to the 17th-century philosopher Baruch Spinoza, who saw God not as a personal deity but as the sum total of the natural laws governing the universe. For Einstein, science and spirituality were not incompatible. Rather, he saw scientific inquiry as a way to glimpse the deeper mysteries of existence. Despite his growing isolation from both the scientific and political mainstream, Einstein remained active until his final years. He continued to write, speak, and correspond with thinkers from around the world. He remained engaged in scientific debates, even as younger generations moved beyond his ideas. He was aware that he was becoming a historical figure in his own lifetime, but he resisted any attempts to portray him as an infallible genius. He often emphasized his own mistakes and limitations, encouraging humility in the pursuit of knowledge. Einstein's health began to decline in the early 1950s. He suffered from heart problems, and by 1955, it was clear that his time was running out. On April 17 of that year, he experienced a ruptured abdominal aneurysm. Doctors offered surgery, but he refused, believing that it was his time to go. He died the next morning at the age of 76. His final words, spoken in German, were lost, as the nurse attending him did not understand the language. His death marked the passing of one of history's greatest minds, but his influence endured. His contributions to physics reshaped humanity's understanding of the universe, while his moral convictions left a lasting imprint on global discourse. His warnings about nuclear weapons, though often ignored in his lifetime, continue to shape conversations about war and peace. His advocacy for civil rights and international unity remains relevant, as does his belief in the power of curiosity and intellectual freedom. Einstein's legacy is vast and complex. He was a scientist, a philosopher, a humanitarian, and a rebel. He was both a symbol of pure intellect and a man deeply engaged with the struggles of his time. His name became synonymous with genius, but his greatest contributions were not just equations or theories, they were the questions he asked and the principles he upheld. His life was a testament to the idea that knowledge and compassion must go hand in hand, and that the pursuit of truth in science and in society is a never-ending journey. Albert Einstein's legacy extends far beyond the confines of physics, touching every aspect of modern science, technology, and even culture. His revolutionary ideas reshaped our understanding of the universe and continued to influence research and innovation in ways that he himself might never have imagined. His contributions to physics, particularly relativity and quantum mechanics, set the stage for much of 20th and 21st century scientific progress. While he is most famous for his theory of relativity, his impact on the world goes far beyond a single equation. One of Einstein's greatest contributions was his redefinition of space, time, and gravity. Before him, Isaac Newton's laws had dominated scientific thought for centuries, describing gravity as a force acting between objects. Einstein, however, changed this perspective entirely with his general theory of relativity. Instead of thinking of gravity as a force, he proposed that massive objects bend the fabric of space-time itself, and that this curvature guides the motion of planets, stars, and even light. This radical idea was confirmed during the 1919 solar eclipse, when astronomers observed that light from distant stars bent around the sun exactly as Einstein had predicted. His theory of relativity laid the foundation for modern astrophysics, leading to groundbreaking discoveries such as black holes, gravitational waves, and the expansion of the universe. The importance of Einstein's work did not stop at relativity. His contributions to quantum mechanics were equally significant, though he remained skeptical of the field's philosophical implications. His explanation of the photoelectric effect, for which he won the Nobel Prize in 1921, demonstrated that light could behave as both a wave and a particle. This insight became one of the cornerstones of quantum mechanics, paving the way for advancements in semiconductor technology, lasers, and even quantum computing. Despite his discomfort with quantum uncertainty, his work directly influenced the field's development. His theories have practical applications in today's world. The Global Positioning System, GPS, which allows precise navigation using satellites, would not work without Einstein's relativity. Because satellites orbit at high speeds and experience weaker gravity than Earth's surface, their clocks tick at different rates than clocks on the ground. Without accounting for these relativistic effects, GPS calculations would become inaccurate within minutes. Similarly, nuclear power, a direct consequence of Einstein's famous equation E equals mc squared, has transformed energy production and medical technology. His work also led to advancements in particle physics, inspiring research at facilities like CERN, where scientists study the fundamental building blocks of the universe. Beyond science, Einstein's influence on popular culture is unparalleled. His name is synonymous with genius, and his wild-haired, absent-minded professor image has been immortalized in films, books, and even cartoons. He became a cultural icon, representing the power of intellectual curiosity and the pursuit of knowledge. His quotes and ideas continue to circulate widely, inspiring generations of thinkers, scientists, and dreamers. Whether through references in science fiction, philosophical discussions, or humorous depictions of eccentric brilliance, Einstein's presence in popular culture remains strong. Despite his scientific achievements, Einstein never limited himself to physics. He was deeply concerned with the moral implications of scientific advancements, particularly in relation to war and nuclear weapons. His famous warning to President Roosevelt about the potential of atomic bombs, followed by his lifelong regret over their use, showed his ethical awareness. He spent his later years advocating for peace, disarmament, and international cooperation, believing that science should serve humanity rather than destroy it. His calls for a united world government and his opposition to nationalism demonstrated his forward-thinking approach to global unity. Einstein also championed civil rights and social justice, using his voice to speak against racial discrimination in the United States. He was one of the few prominent figures of his time to openly support the struggles of African Americans, condemning segregation and oppression. His friendships with activists like Paul Robeson and W.E.B. Du Bois showed his commitment to equality, despite the risks involved in an era of intense political scrutiny. His courage in speaking out against injustice further solidified his role as a moral leader. As science continues to evolve, Einstein's theories remain as relevant as ever. The discovery of gravitational waves in 2015, a century after he predicted them, was a testament to his lasting influence. Quantum mechanics, which he helped shape, is now at the forefront of technological revolutions in computing and cryptography. His ideas still challenge scientists to explore the unknown, pushing the boundaries of human understanding. Reflecting on Einstein's life, it is clear why he is considered the greatest brain of the 20th century. His genius was not just in his ability to develop groundbreaking theories, but in his approach to thinking itself. He questioned everything, refused to accept conventional wisdom, and sought deeper truths beyond what was immediately observable. His ability to blend imagination with rigorous scientific reasoning set him apart from his peers. Unlike many great minds, Einstein's influence was not confined to one discipline. He left a mark on physics, philosophy, politics, and humanitarian efforts alike. His philosophical reflections on science and life remain inspiring. He believed in the power of curiosity and the need to maintain a sense of wonder about the universe. He saw scientific inquiry as a deeply human pursuit, one that should be guided by ethical considerations. His humility, despite his towering intellect, made him an approachable figure, reminding the world that even the greatest thinkers should remain lifelong students of the world around them. Einstein's legacy is one of intellect, morality, and vision. He revolutionized science, shaped modern physics, and stood as a voice of reason in turbulent times. His contributions continue to drive technological and philosophical advancements, proving that his influence is far from over. More than a century after his most famous discoveries, the world still looks to Einstein as a symbol of boundless human potential, reminding us that curiosity, courage, and compassion are the true marks of greatness.